It's going. There we go. Okay, so this is called section 4-6, I believe. And this is called the graphs of tangent x and cotangent of x. Okay, y equals tangent of x, and y equals cotangent of x. And so y equals tangent of x looks kind of different than the functions you have seen so far. Okay, and so if I were to take a line, hello, how you doing? How you doing? Okay, and I'm going to make my tangent graph here. I'm also going to grab a circle. Where's a circle? Here's a circle. I'm going to make a circle over here. I'm going to make it a little unit circle. Oh, I don't want arrows. I can fix that. I'm going to make it that way. I can get rid of the arrows. Okay. I'm going to make a little circle here and here. And I'm going to go here as well. And this time I'm going to go down here. Okay. And I'm going to call this the point, this is 0 radians, and it has coordinates 1, 0. And this we're going to call pi over 4 radians, and it has the coordinates root of 2 over 2, comma root of 2 over 2. You're going to have to be able to reproduce this on on Wednesday. Pi over 2, and this has the coordinate Thursday. No, when? And over here, I'm going to call this negative pi over 4, and I'm going to call this root of 2 over 2, comma, negative root of 2 over 2. And then this is going to be the point negative pi over 2 radians. And this has coordinates 0, comma, negative 1. Good with that? Yes? Good. Now, pay attention. So, oh, that's a bad screen. I wish we could get some blinds in here. Okay. So any case, how's my screen is the lights? I don't know. So if I were to graph this, say I start here at 0. I'm out at the graph of y equals tangent of x. Y equals tan of x. What's the tangent of 0? Anyone? Tangent is 0. Tangent is 0. What's 0? Y over x. What's 0 over 1? 0. Okay? What's the tangent of pi over 4? What's the tangent of pi over 4? Thank you. Who said that? Me. Who's me? Very good. Me. It's 1. Okay? You get that? Okay? Now as I get here to pi over 2, okay? As I move out here to pi over 2, what's true about tangent? It's undefined. Why is it undefined?
It's 1 over 0.
Because the ratio of this to this, as I get closer and closer to here, the ratio of the opposite side to the adjacent side gets bigger and bigger and bigger and bigger, right? And it gets so big that it becomes infinite. So what happens when you're doing the graph, okay, is you get an asymptote there at pi over 2, okay? So this thing looks like the tangent function. If you're going to graph it, we'll graph it green. It from here, it's going to go up like this, okay? Now, because functions, you don't like to have what's called a discontinuity in the middle of it, we're going to continue, instead of going this way, we're going to continue backwards. So what is the tangent of negative pi over 4? What's the tangent of negative pi over 4? What's y over x in this case? Negative 1, okay? And then it goes to negative infinity. So if I go backwards, okay, to over here, which we'll call this graph negative pi over 2, this asymptote here. What happens here, and if I call this negative 1, oh, it's very colorful. It's like Christmas. okay? And I go down here, kind of looks like this, and this is negative pi over 4, okay? So to graph the tangent, we go forwards, then we go backwards, and we look at what's happening behind to see one period of my tangent function. But as I go around here, is tangent negative or positive in this quadrant? Negative. So what happens here is tangent starts down here, and it goes up again like this, okay? This is bad, but it goes like that, and it does this picture forever and ever, okay? That's not very good graphs, and it does that every pi radians, like that, okay? We'll graph one of these in a minute on your calculator. So if this is pi over 2, pi later is going to repeat to 3 pi over 2. And the next asymptote over here would be negative 3 pi over 2. I made that kind of stretched out and stuff, but that's what it looks like. So there's some things that you should know about tangent. Its period is equal to pi, okay? And unlike sine and cosine, the period of tangent, its period is pi, okay? And b, which is a thing that, which kind of tells you how fast the graph is going, b, unlike sine and cosine, is equal to pi divided by the period. And conversely, p is equal to pi divided by b. So if you know the period, you can find b. If you know b, then you can find the period, right? But instead of having 2 pi up there like you do for sine and cosine, you have pi there. Got it? All right. Okay. All right. So, anyway, then you got to know some other stuff. The domain, okay? Domain of tangent is x is not equal to multiples of pi over 2, because that's where I have asymptotes. And the way you write that is pi over 2 plus n, I wrote pi over 2 plus n times pi, where n is an integer. So that means that any multiple of pi over 2, whether I add pi or subtract pi, I'm going to get the tangent function is going to be undefined at those x values. Likewise, it has asymptotes at x equals this exact same thing, okay? Pi over 2 plus n times pi. That's where you find all the asymptotes. All right? What else do I have to tell you? The domain I talked about, it has intercepts. I need more room. I could go down. That's okay. It has intercepts. I think red shows up better. Intercepts at multiples of pi. Okay? So intercepts at x equals 0, at x equals pi, at x equals negative pi, at x equals 2 pi. The way you would write that shorthand, at x equals n times pi, multiples of pi. That makes sense? So 0, pi, every intercepts also known as zeros, okay? Or, sorry, I should have said x intercepts, and multiples of pi, okay? And what else do I have to tell you about that? Asymptotes graph. The other thing about tangent, it is odd. Odd, not meaning weird or anything like that, but odd means that y equals tangent of negative x, like that, is equal to negative tangent of positive x. Can you see that? Negative tangent of positive x. And it has origin symmetry. origin symmetry, which means that if I were to take that function and rotate it, okay, around the origin 180 degrees, it would look exactly the same, right? Like a propeller, right? If I took this and spun it, do you see that it would look exactly the same? Okay? That's origin symmetry. Good enough with tangent? Here. Okay, so how would I graph? Let's just jump. Should we jump? How would I sketch the graph of, so did I need to go back? Anyone want me to go back? Okay. So what if I said sketch, y equals tangent of 2x without your calculator. So I would make the graph better. Shouldn't be dotted line. That's okay. But so if this is the, let's make that solid. So I'm going to go over here. Up, x, y. Now I'm going to make dotted ones. Okay. What's that 2 in front going to do to it? It's going to speed it up, right, by a factor of 2. Okay? So instead of the asymptotes being at pi over 2 and negative pi over 2, now they're going to be, it's going to squish it, right? So what would they be at? Pi over 4 and negative pi over 4. Okay? It's going to make it go faster, right? If you don't like that, then you could use the formula. If I know that the period is pi divided by b, okay? So don't get confused. For tangent and cotangent, it's pi, not 2 pi. And I know that b is 2. That means that the period is pi over 2. So from here to here is pi over 2 radii. Halfway between there would be pi over 8 and negative pi over 8. And then if I go up to, say this is 1 and negative 1, so this function is going to go, and it's going to still have a 0 the same place, but it's going to kind of go like this through that point, show that you know that it goes like through this point right here and through that point right there at pi over 8. And then it's going to continue like that every pi over 2 radii. Yes? What would y, just real quick, what would y equals negative 3 tangent of x look like that? What would that do to my graph? What would the negative 3 do to it? It's going to make it flip over the x-axis. Whoops, this should go through, sorry, this should go through 0, 0. I messed up. It should go through I messed up. But it should go through 0, 0. But y equals negative 3 tangent of x is going to, where's my, here. It's going to have a period of pi still, right? So it's going to go from negative pi over 2 to pi over 2, but this is going to make it go the opposite direction, and this is going to make it stretch by a factor of 3. So if this is negative pi over 2, and this were pi over 2, you need to indicate somewhere 1, 2, negative 3 down here, 1, 2, positive 3 up here, and show that you know that this thing is going to stretch, it's going to go the opposite direction, right, because it's negative. So it's going to come from the top, it's going to go through here at negative pi over 4, positive pi over 4, and then it's going to go through negative 3 down here. And so this graph is going to look something like this. It's going to go through 0 like this, and it's going to do that over and over again, okay? Over and over again. So you should sketch in a few periods and asymptotes so you know it's doing. Questions? I gotta teach you one more. What time do we get out? 10 after? Uh-oh. I got 8 minutes to teach you about cotangent effects. Okay? I'm gonna go fast. So y equals cotangent of x. How would I do that on your calculator? Yeah, there's no cotangent button, so if I were doing it on your calculator, you'd have to go y equals 1 over cotangent of x. Just to show you, I want to show you because it's kind of interesting. Okay? If I bring my calculator up, I'm going to go from, I'm going to set my window now to negative 2 pi up to 2 pi, 2 second pi, and I'm gonna change my y min and y max because I want to see negative. So I'm gonna go from negative 5 up to positive 5, and then I'm gonna plug in that equation. Y clear. So y equals tangent of x. I could do cotangent of x. Y equals 1 over tangent of x. And if I hit graph, I get this thing. Okay? And it looks very, very, very similar to y equals tangent of x. Who could tell me the difference between that and y equals tangent of x? Yes, Sarah? Right, it's going the opposite direction, right? And it has different asymptotes, right? Because the x and y, this is an asymptote at 0, and then it has another asymptote at pi. Still has the same period, right? And that everything shifts over 1, and it's flipped. It's moved over pi over 2, and it's flipped because you're dealing with x, y, or switch. Does that make sense? Okay? And I can show you on the unit circle where that comes from, but you can look at that. The other thing, when you're doing some of these on your graphing calculator, some of you, it will draw, if you have an older TI, it draws in the asymptotes. You know what I mean? So when you're graphing it on your, calculator, it's kind of bad. It's kind of bad math to draw in, if this is y equals cotangent of x, and you do something like this, and then you go, and like this, because a lot of your calculators, if you have an older TI, it draws in the asymptote. Don't draw this part, okay? Because it will draw in the asymptotes, and you don't want to draw in the asymptotes. Yes? Great.
The y equals 1 over x, should it be t?
Oh! Yes, it should be t. I'm sorry. Yeah, y equals tangent of x. Sorry. Cotangent is 1 over tangent of x. Right? Thanks. And then, just real quick, domain of this, okay? Domain x is not equal to multiples of pi. Okay? Asymptotes. X equals multiples of pi. Okay? Intercepts, x intercepts at multiples of pi over 2. Okay? X equals pi over 2 plus n pi. Domain is, I already did that. Okay? The range, okay, is from negative infinity to infinity. Did I talk about that with tangent x? Oh, tangent x is the same, okay? The y values, unlike sine and cosine, they go on forever and ever and ever and ever, okay? Sine and cosine only go between negative 1 and 1. Tangent, because you could have an opposite over adjacent as big as you want. It goes on forever. It's also odd, okay, because this is a rotation over the, if I flip this over the origin 180 degrees, it'll look the same. It's got origin symmetry, and it also has a period equals pi, okay? So I know I rushed through that, but you'll have some shifts of that and things like that. You should be able to figure it out, okay? Not too bad. Okay, we're done. I'll teach you on the board tomorrow.